Morning guys. Today we're going to take a look at a slightly harder example of rectangle problems. It's non-algebra, meaning there's not really much to solve in terms of x's, but it's a pretty comprehensive problem because it pretty much incorporates just about everything you need to know about rectangles, okay? And the one we're going to take a look at is on page 9 of the Unit 8 Classwork packet, example 5, all right? All right, first things first, let's actually write stuff in that we know because it's a rectangle, okay? So I'm actually going to draw in each corner, I'm going to draw these 90-degree angles, right? I know that there are 90 degrees in each corner. That shouldn't come as a surprise. I should also know that each one or each piece of the diagonals is congruent, right? The diagonals are congruent and they bisect each other. With that being said, there's still more that I can fill in for this problem. If this is 26, this over here is also 26 because opposite sides of parallelograms, of which a rectangle is one, are congruent. Similarly, by isosceles triangles, I know that because this is isosceles, this is also 52, right? This triangle on the right over here is exactly the same triangle, so it's 52 and 52. Then I know that because there are 90 degrees in total, and then I've already used 52 of them, that leaves 38 degrees for each of the other ones, all right? So right there, I've actually filled in just about everything that I'm gonna need from my diagram, right? The only thing that's really missing is this side length over here, okay? And so we're gonna talk about that in just a second. Notice, did I forget something? dB is 42. Yeah. All right, so guys, I'm gonna actually use, do I even have a different color? I hope so. Let's see, blue, purple, green. Okay, so I'm actually gonna highlight a right triangle for us. Does everybody see that right triangle there in the corner? What I'm gonna do to kind of like make this diagram a little bit less busy, I'm gonna redraw that triangle, okay? Like so. This is 26, this is 42, on this I'm looking for, okay? So I now have a right triangle with two sides that I know, and thus I can use the Pythagorean theorem to find the third. Notice that in this case, instead of being given two legs, I actually have a leg and a hypotenuse, right? Because the hypotenuse is across from the 90-degree angle. So that means I'm going to plug in not for A and B, but for A and C. Let's go. So I have 26 squared plus B squared equals 42 squared. So let's see, this right over here should be 676 plus B squared. I actually don't know 42 squared, so I'm actually going to have to do that one. All right, 8, 0, 8, 16, 4, 6, 1, 7, 1. Subtract 676 from both sides. Okay, that's going to become a 14, 15. So I get 1,088, I think. Is that right? Yeah. So B squared equals 1,088. Oh my gosh. Sorry about that, guys. And then to undo a square, I'm just going to take the square root. So I'm going to say rad 1,088. All right. Is that actually a perfect square? I don't think so. So I'm just going to leave. I know it could probably be simplified. All right. But for right now, you actually have my permission to leave it alone. So this side over here is actually rad 1,088. And so would this one. Okay. Now, with that being said, let's go down the list and see if we actually know everything we need. AC, this diagonal, is the same as this one, so that would be 42. EB, well, that would be half of this diagonal, so that would be 21. BC, well, we already did that, that would be 26. AB, well, we said it's rad 1,088. Angle ADC, the angle in the corner here is 90 degrees. Angle ABD, let's see, this one over here is 38 because of complementary angles. Angle BCA, let's see, this one right here is 52 degrees. And angle DEC, Okay, no, didn't find that one. Let's talk about that. DEC. So I've used up 38 and 38. How many degrees are left in a triangle? Well, I know there are 180 total, so I have to add the two 38s, which gives me 76, and subtract from 180, right? So I'm going to get 104 degrees for angle DEC, all right? So again, guys, notice that there were some parts of this problem that were easy. Knowing that the diagonals were congruent, knowing that the opposite sides were congruent, knowing that the 90-degree angles were in the corners. But there were other parts that required the Pythagorean theorem, and there were other parts that required isosceles triangles and triangle sum, okay? So the hardest part about quadrilaterals is not the quadrilaterals themselves, it's the fact that we have to bring back information from Unit 5, and in some cases earlier than that, in order to actually solve for our unknowns.